Hello everyone, my name is Jordi Mellado and I'm from the Chemometrics team at Iris Technology Solutions. I'm going to talk about the monitoring solution implemented in the chocolate production case of study in the framework of the multiple project. Jotis is among the leading food industry companies in Greece, having one of the finest research and development departments. The initial goal of Jotis, which was founded in 1930, was to provide children food made with pure ingredients harvested in Greece in order to reduce child mortality. Thanks to continuous innovations, they extended their product portfolio to products such as pastries, beverage, confectionery, desserts, cake mixes, among others. Many processes are involved in chocolate manufacture, from the post-harvest handling of cocoa to its transformation into chocolate. Jotis takes an important role in the latter stage. Taking a look to the flow diagram from left to right, the transformation process involves the mixing of the raw materials, cocoa liquor and cocoa butter, with sugar and milk, to obtain a mixture that will be refined to eliminate the granules. Then, a conching process is undertaken to develop the flavor and remove bitterness and remaining moisture. After that, chocolate is tempered in order to obtain a stable crystallization of the cocoa butter and, therefore, a smooth chocolate. Finally, the chocolate is poured into molds to give it the desired shape. During the whole process, there are important quality control points to evaluate. Different processes have been monitored during the present project, and we will focus on two of them. During the conching process, all solid particles are coated with the fat from cocoa butter and evenly mixed through the matrix, which changes the flavor profile of chocolate. Moreover, a viscosity reduction is achieved thanks to the friction generated and the increase in temperature during the process. For this reason, particle size and viscosity are important parameters to be evaluated. Tempering has the aim of achieving a more stable crystalline configuration of the fat. In order to accomplish that, chocolate is heated at around 40 degrees Celsius, since higher temperatures boost the nature of the milk proteins, which create agglomerate, resulting in a thicker chocolate. After that, the chocolate is cooled down in order to give it a lustrous appearance and melt in the mouth properties. Tempering can be monitored by measuring the cooling curve with a temperometer, which retrieves an index known as the temper index. Therefore, the objective in this step is to monitor the temper index. Two different sensors have been evaluated and integrated at Jotis facilities for the measurement of viscosity and particle size during the conching process. Both of them are based on the same physical principle, which is near-infrared spectroscopy in diffusive reflectance mode. On the one hand, IRIS proposed to test the benchmark Visum NIR inline sensor, which has a detector for 256 spectral channels. On the other hand, Sonorix proposed using a simpler sensor based on 16 spectral channels. The working flow of both integrated prototypes is straightforward. Chocolate spectra are acquired in real time, online, inside of the conching machine via an integrated software, which has chemometric models embedded on it. The same software displays the predicted values for viscosity and particle size, and finally stores them in a file. Let's watch a short video with the demonstration of the monitoring solution integrated in the conching process. We can see the inner part of the conching machine in which the chocolate is stirred. The chocolate flows through the pipes until it reaches the connector where the two sensors are connected. First, we see the Sonorix prototype, and then the Visum line. That's the chocolate flowing inside the pipe. Sensors are software control with a laptop, which are linked through Wi-Fi. Both sensors have a similar software. Spectre is displayed in the main screen of the software, which displays characteristic features of the chocolate. Viscosity and particle size predicted values are also displayed, which are calculated through the chemometric models implemented in the software. Here, we see the spectra retrieved by the sonoric sensor, which looks quite different due to the number of spectral bands the detector has. Also, here we have the predicted values. Several conclusions have been reached during this project. Viscosity can be accurately measured with both sensors tested. Particle size can be also evaluated with a Visum inline device, but not with a sonoric sensor. The main reason for that is the number of spectral bands Sonoric's prototype has. Therefore, seems that for this parameter not enough information is gathered to develop robust chemometric models. The most important conclusion is that chocolate production can be successfully monitored through the inline measurement of NAR spectra, which will have a high impact in the food industry by reducing time and economic losses in the quality control of such products. Thank you for your attention, and if you have any question, don't hesitate to contact me at the email that is displayed on the screen.